DraftScience video presentation. Voice is not very good. Anyway, I didn't try it, first. Where are we? Alright, so it has occurred to me another reason to doubt the wave theory, the theory that whatever goes through the slits, that somehow between the slits and the screen, the photons bang into each other in some way and cancel in some way, and then get to the target, with missing photons, versus, I'd say, a more logical theory that the photons are just in some way broken, and that in the process of going to the screen, the pieces can just be, you can just take the head off of one and the tail off like a Mr. Potato Head. They go in as Mr. Potato Head, all the pieces fly off, and then you just, look on the screen to see where you're made a potato head again. No big deal. Anyway, so I was thinking of color. And the fact is their theory now not only has the obstacle of explaining why, forces don't interact with forces, is the argument fundamentally. You can't shoot two laser beams at each other and have them bounce off. You can't get magnetic fields to react to a magnetic field. I mean, it has to actually go to a piece of matter. You can't sense it, you can't control it, you can't manipulate it. You can't use a field to manipulate a field. You have to use matter as a conduit. And that's true of gravity and, all the forces. All this stuff moving the speed of light appears in most all cases, I suppose, except these ones in some sort of imagined space. Force, you just can't get a force to hit another force. It just doesn't happen. And so they already have the burden of explaining how just going through a slit somehow alters the force in some sort of way that now it can interact with another force, that a laser beam could hit a laser beam. Now, I think they know that if we could actually put a high enough powered laser through and we actually see the tracks of the laser beams and all that stuff, it's not going to happen. But anyway, we're never going to image this interference. But anyway, so that's a substantial burden that's never been met. We don't need to have any kind of explanation for this exception to the rule. Just like gravitational lensing is an exception to the rule, and there's no obligation to explain why that exception exists, or how mechanically it makes any sense. Okay, so the fact is that this experiment separates light. So it's a the spectrum will be revealed like a prism. It's doing something very similar to a prism in the sense that it will separate the colors of light. And the only way it can do that is that red light has to only react with red light, and blue light can only react with blue light. So they're sort of stuck with a dependency there, where they have to say that somehow, these photons have all kinds of magical powers, and now they have this new one where they can recognize whether the other photon is the same color. And that doesn't seem plausible or reasonable. But anyway, that's the state of things. So I just thought I'd throw that in. I've never heard anybody mention it before. That's another burden of explanation. Now, from my perspective, I don't have to worry about it because the blue light goes everywhere, and the red light goes everywhere, and the green light goes everywhere. It's just that the pieces aren't a photon in some locations, so the same energy is going to every single location. I don't have to, in a particle theory, you don't have to destroy the energy. You don't have to destroy the bits of the photon. You just reduce the number of photons that actually produce a visible photon, which is perfectly consistent with what appears to happen, because it does appear that you get less light. As you put the photons through the obstacle course, less and less photons make it to the other side. Anyway, so the Mesokosmos guy has posted another comment, which is good. It was a little weird that he ceased to respond in some way. But it seems also weird to me that the very video he's commenting on, I think, answered some of these questions, and it seems like the answers just didn't work. And I'm saying, how simple do I have to, you know, I've really gone to some lengths to try to explain everything really, you know, draw it as clearly as possible. And yeah, it is physics, and you know, you can't make it, you know, I can't make it a straight line. You know, it has to do some A to B to C to D thing. It does have to do some bouncing. You know, I can't just put the ball there and say, look at the ball. You know, did this bounce around? So I don't know what the failure to communicate, I don't know what its cause is. I mean, I have to take half the responsibility at least, but I just don't know if that's, I just don't know. So anyway, we'll go through this again. And it's disappointing, but I don't see any alternative. It does seem that his position is one, well, maybe I'll load one of his animation thingy here. Preview a simulation document. Okay, we'll go there. So he's calling the two methods of approaching the problem, the theta method and the PLD method. And you know, frankly, his PLD method is a theta method. He's just calling it whatever, beta or something, whatever the other symbol is. It's an angle method again. But both of them, the theta method, it does have an angle, but the angle does represent a path length difference. You know. So, so this is a little, you know, not intuitive for me anyway. I mean, x coordinate, I'm changing variables that are the product, and I don't know if I want to do that. I want to predict the result based on what I put in as variables. I don't, you know. But anyway, so it's not incredibly intuitive to get this to work. But anyway, he's just pointing out that these different approaches don't get the same answer. And I guess in a way he's pointing out that, isn't it strange that we don't have any, that this should already be settled, you know, what the right answer is. And it's just part of the failure of physics, you know, all this big talk about how it's the most proven theory in the history of mankind and all this nonsense and the most accurate and the most everything. And yet we don't have any of this, you know, depth in volumes of detailed information about how slit experiments work. You can't go to some website and get, well, this is what a, you know, the certain slit widths and arrangement, this is what it produces on a screen 2 meters away, it's this many centimeters, blah blah blah. There's no website that does that. There's no place to go to get that information, and that really should be already stored somewhere. This all should have been done long ago. And that's part of the joke here, is that I don't think they did it because, frankly, the real answers don't match what their simulations are producing. And that would become obvious if they had that reservoir of real data. So anyway, blah, 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 blah. It's nice to hear that you settled down with the node size dilemma. Well, I don't know if it was really a dilemma, it was just a little bit of a controversy. And it frankly doesn't change much, except, again, it doesn't change how you predict where a node is going to be. It, beyond saying that I couldn't use my simple trick, that the simple just draw it way won't work. Okay, yeah, because one node doesn't tell you every other node. It still sort of does, because if you know exactly what, frankly, a circle is always a circle, so the rate at which it's going to speed up. You could think of it as stick falling over, right? I could just take a stick and drop it. The rate at which the stick falls is the same ratio as the nodes are being produced, essentially. It's the same mechanism. It's a constant, and it's you know, we're just talking about the fact that it moves faster the further along it gets. There's more energy going this way at the end, and less energy going that way. And in the beginning, there's more energy going this way, and less energy going that way. Anyway, it is safe to conclude that the width of the nodes varies depending on 3 parameters. Everything depends on the 3 parameters. So yes, the 3 variables are all there are, and frankly, this shouldn't be that complicated. We shouldn't even be doing all of this, because the 3 variables are so basic and unambiguous that why is there even a controversy? So the screen distance, the wavelength of the slit, the wavelength and the slit width. I would argue that it's not the slit width, okay, because you can do this with an impediment. So again, it's the distance between the surfaces. And that also seems to be what's really missing. You know, his animation sort of pisses me off, because it has this traditional shit drawing, you know, which doesn't represent the single slit really. I mean, if you do a single slit with a wide opening, you can get 70 or 80 nodes on the screen. I mean, a lot of little bars. By their theory, the 3rd or the 4th bar should be like 1% as bright as the first one, and it's not. I mean, you can see that plainly visually. So there's something wrong with that assumption, and you know, but here it is, just kind of built into everything, and I think that's, you know, kind of evidence of something too. So anyway, he has these vectors going from one point in the center of something, and it's like the whole point I tried to make in the video yesterday is that there is no center. So maybe he's doing you know, some sort of mathematical trick where the center, he has now made it relevant because he's somehow dissecting the triangles, I would say, are produced. And so we'll see if we can figure that out, but I can't understand exactly what he's doing. And you know, he's sort of assuming I do, and I don't understand it. I don't. So again, I can only draw what I know, what I'm arguing, what I'm saying. So I don't think your math is necessarily representing what I'm arguing is the case. So I guess I won't go there yet. All right. This way, they all contribute to a ratio of the change together with the angle of the phase. See, now the angle of the phase, I said before that it seems to me you're assuming these are waves still. You know, they're not waves, okay, in any real respect. It's like calling bullets waves. I just don't think it's rational. It's a, you could say it was, oh, you know, I dodged a wave of bullets. You could say it, but they're not interconnected. They're not pulling on each other. It's not a medium. Blah, blah, blah. I go through all the reasons why I wouldn't use this kind of terminology. Alright, I've plotted the change curve a few times, but it seems there is no simple function for all cases. Well, I think there is. Alright, so let's just go back. We'll draw the basic diagram, and I'll try to figure out where him and me are not seeing this the same way. So as I attempted to point out, there are 2 points in the experiment. So whether I put an impediment here or I put an opening here, it doesn't matter. These are essentially the distances of the surfaces, or the width of the impediment. So this is the D that's relevant, okay? But it's sort of irrelevant when you start to realize that both of these point sources, okay, they don't have anything in common. This is not a common point. This line, this notion that they shoot something in the middle and this thing in the middle is real is fallacious, because this is a tiny distance, you know, 1/4 of a millimeter. This all happens inside of 1/4 of a millimeter. It's not magnified by distance. So the only way you can magnify something by distance is you have to have it diverging. You have to spread things, okay? They have to be, you know, and that's not happening here. This is a convert. This is the exact opposite. It's not going to do you any good to project things in and then say I'm going to magnify them by distance. You can't do it because they're not going to get wider and wider and bigger. They're just going to get further away and stay exactly the same. So it doesn't matter whether I'm a billion light years away or a foot away. This point, okay, is doomed to produce the same result. It doesn't have any, there's no options, because it's all inside of this 1/4 millimeter. That all happens there. It doesn't spread and create a node. Part of it can't be over here and over here and over here. All of it has to be in here. Every bit of it has to be in here. It can't make a big giant node. Now, do you get that? All right. So this whole idea that these fake lines that aren't a wavelength longer, by the way, right? One of them isn't a wavelength longer, so technically it doesn't fit in the description of what a fringe is created by. It's overtly not a path length. A wavelength longer in path length, which is the description of what you're looking for a center of a node. So it by definition isn't even fit. So this is nothing. This doesn't mean anything. And what you're really comparing are two lines that go in the same direction. So you're saying here's a point in space. Okay, now one of these lines I'll draw and I'll establish it as a distance. And I'll say it's whatever it is, L. And then I just want to know how, when, you know, in this, if I moved it to a position, will I get it closer or further from a path length difference? Now, as I pointed out, I can make this an on or an off right here. So right at this point, right where this is still 90 degrees, this is an L, okay, it's a standard length. Gee, I just don't want to say anything to confuse anybody. So just understand these are two separate circles. Okay, this one's creating an arc, and this one's creating an arc. Do you get that part? I mean, these two circles don't match. It's like one of them's here, and one of them, you know, how to draw it right. They're a millimeter apart. I mean, they're close, but they're two different circles. Okay, so one of them is here. So they're two different circles. So they're not in the same dimensions. So you can't, you got to be careful of assuming. You have to always account for this distance. So you can't just assume this one is in the same position as this one, and, you know, it doesn't make any sense. All right, so right at this point, right? So if I just made this, and I just get outside of this silly zone. So let's just say this zone is dead, because this zone can't be part of the fringes. This is 1/4 of a millimeter. It's a tiny place. It's not part of fringes. So the first place that's possible to have a wavelength of difference is this line going to this point. Right? So now they're both technically going in the same direction, right? I mean, I didn't change this. This is still 90 degrees, but I clearly did change this one. Okay, but it's not going in the same, you know, an opposite direction. So this is the first node this way, the first possibility. And this one's going to be on or off, completely dependent on whether I have an odd or even number of wavelengths in this number, right? Because I'm making this triangle. So I know this L distance, right? I can know that variable. I can just establish I want to go 5 feet away or whatever the number is. And I can establish the L. So I know one side. I know this, right? Because I know the width of the slit, so I know this variable. And all I want to know is this hypotenuse, right? And so I just do the simple square this, square that, and then I square root that, and I got the answer. Now it doesn't predict where it's going to be, but I can certainly predict it by changing this number. So if I change this number to one kind of number, like 15.7 or something, then I'll get a result here. If I use the standard number here, a whole meters here, then I'll get a number here that'll indicate that it is one wavelength, okay, longer. This will be an even number, and that'll tell me that I'm one wavelength longer, right? And I could do the same thing. I pick a number where I'm going to definitely get an off. So it can be either one depending on how long I make this line. So we know the nodes, this middle node is made out of movable nodes. They can be a certain distance apart, or they can be a certain distance encroached on each other, you know, over each other. And those are the possibilities. All right, so we're just saying, okay, so now let's just forget about that part and just say I pick a place anywhere here, you know, in space. This one's going to be the distance I know from this one. All right, this I know, and we're just trying to find what this line is and whether or not it's a wavelength away. Now, what I'm thinking to myself is, yeah, I could just make a little computer program that goes through all the permutations. Okay, so it just sits there. It establishes a distance for this, establishes a distance for this L. So it's just going to tell me every dot on this line, on the curve from this 90-degree angle. So it'll tell me every one of these, the answer to this, by knowing this and knowing this. Now I don't know whether you can you do the angle thing? I mean, can you do the side squared times side squared hypotenuse thing if it's not a right triangle? See, I don't remember all these. I didn't remember all my algebra. Anyway, if I can, then that's all I needed to do. So all I want to know is this a path length difference? If it is, I mean a wavelength difference. If it isn't, then we should be able to get how far off it is. You know, just have a number. It's, you know, 15, you know, 0.2, and it needs to be 15. It needs to be 16. You know, and at 16, that's when there'll be a node, and then it's 7. You know, all the whole numbers, it'll be a node. So anyway, so that's all the math I'm seeing is, you know, two sides, you should be able to know everything else. Now maybe he's bisecting this with a, you know, a normal line, and then using the normal line to create new triangles that have right triangle in them. But you'd still have to have two of them, I would imagine. I'm trying to figure out what the triangle here would be, because you're still, see, this one's kind of an obvious triangle off the normal, but this one isn't as obvious. This is a four-sided object, not a three-sided object you get over here. So this normal doesn't help you very much. But anyway, so that's the basic setup. It's the path lengths are all in this distance, and it's really, I mean, I use this example of visually you could sort of understand it. If I tilt this a little bit, you can see one of the wavelengths. You know, if there were little notches on here that were a ½ inch, let's say, and as I tilt this up, you could say it's not, don't think about looking for the notches, just think how much of the object you see. So there's a point where you see 1 centimeter, and then there's a point where you see, oh, I see 2 centimeters worth, and then you see 3 centimeters worth, and then you see 4 centimeters worth, and then 5, and then 6. So it's the same idea as if you were just looking at it, and it was something that was moving like that. There's a point where, you know, you can just see it happen. You can visually see it getting longer, and you can see the fact that as you move it this way, it's not getting much more. You're not seeing as much. You see a lot more for a tiny little change here. Tiny change in the angle gives you a lot more vision. And once you get to this point, I mean this point, you're getting less and less increase in the length per motion in the curve. Which again just means that the nodes are small to start with and get bigger and bigger. Alright, so that should be enough of a background. But I don't think there's no dispute. I mean, if people are still disputing that the central maxima is an on, you know, you're saying it's an on. I'm saying it's more likely to be an off, because technically the first maxima is here at this edge and at this edge. So, you know, this doesn't work. I mean, this thing here, this idea of saying there's two lines that are going out, yes, inside of 1/4 of a millimeter. You already know that the fringes are only made out of light you're magnifying, the image you're magnifying. That's all the fringes are the stuff that gets magnified. The stuff that doesn't get magnified with distance is not the fringes, and certainly isn't going to be relevant to defining where the fringes are. Just as this line is set, you can't dispute what this is going to be. The path length difference between this line, okay, that goes from here to here, and this line, which goes from here to here, the path length difference between those lines is this distance. There's no disputing that. And if this distance is not an even number, this is an off. And if it is an even number, a whole number, then it's an on. You can't change that. And once you can't change that, even though these are not evenly sized, you can't change. If you know this one, you probably know this one. Anyway. Sorry. Let me fix my throat if I can, and I'll be back. Alright, so just to be clear, what I'm looking for is somebody, so he says there seems there's no simple function for all cases, and I'm arguing, of course there has to be, there's not enough variables here. So we agree on the D variable, we agree that, okay, I agree anyway, I'm stating the L is a distance. Alright, now I would argue that you really have to do this on a curved screen and all that stuff to make it make sensible. But regardless, we know one of the distances. This line is a distance. Alright, I'm arguing it should be this distance from an arc and all that stuff, but it doesn't matter. It's a set distance going in. You're saying here from this point, there's a distance. Not from this point, from this one. These two can't have the same distance. Okay, that's like their theta math where they pretend they're parallel lines. That can't give you the right answer. Alright, so you know this distance, you know this distance, and what you want to know is this distance. And so I don't know why this shouldn't be that complicated. And yes, that can be an angle here, okay, or that can give you an angle here. Those could be angles that you're saying this second node's angle. But the real thing you want is this angle. I mean, what you want, so technically you want something, you know, if you create a third arc and put it in here and then say, well, it's 30 degrees on the third arc, that's not very helpful. I want to know the distance from this point here, how far on this arc. That's what I want to know, right? Because knowing anything else is way too complicated for you to get the right answer. You're saying you're going to be able to extrapolate this triangle onto this other, you know, third half circle. I mean, let's concede this one's creating a half circle, this one's creating a half circle. All right, now you're saying let's try a third one which is in between those two, and so I'll give you an answer on this one even though I put the variables in for this one. And I was looking for the angle on, I mean the distance from this one. So, you know, there's got to be some agreeable place you're starting from. So if you start from, if you use this normal line merely to establish that you're extending this arc a little bit, okay, in the past 90 degrees, okay, to establish a point for counting distance, well, that might work. But I think it would just be easier to figure out the distance from this line. Well, anyway, but that's what's still lost in this, in my opinion. So just tell me, I want to know the triangle. All right, I just want to know, if I give you L and I give you D, can you give me this hypotenuse? All right, and if you can, then all we have to do is figure out how many, you know, just go through the simple equation over and over again, and I should be able to tell you what it is at every one of these points. And this shouldn't be that complicated, you know, because what I'm really just changing is I go from perpendicular to whatever, perpendicular. I go from not perpendicular to perpendicular, something like that. Anyway. Alright. I made geometrical drawings. I just don't argue this argument here. There's no simple function for all cases. I think there is. So I don't think there's any reason to believe there isn't. I made geometrical drawings and found that these phase lines are always outside the circle's reach. See, I just don't know what that means. If you take the first node distance as a center. So again, I don't take the first node to have anything to do with a center. So that's the dangerous part of what you just said, equals radius. So, I don't know. And draw a circle around it. So now he's talking about putting a circle around this, and then there'll be distances that will, I don't know, no, that won't work either. So, sorry, I can't quite visualize what you're describing. And found that the phase lines are always outside the circle's reach. I just don't know. One can plot phase lines like fans spreading from the center of the slit. Yeah, you can, but I'm not interested in that, frankly. So again, you keep saying phase, and you keep saying words that just aren't going to, you know, you're still talking as if this is some sort of wave thing. And it, you know, there's no reason to, in my opinion. But anyway, like a fan spreading from the center of the slit, origo. So he's doing this origo thing again, which is some sort of midpoint, which I think doesn't create clarity because the waves aren't coming out of the middle of the slit. Just as when you put the single impediment in the way, they're not going through the center of the impediment. You know, to all directions with as many lines as there are wavelengths in the slit width. So you're making a whole bunch of, you're doing some kind of Huygens thing now. You know, I don't know. You know, trying to make a bunch of points from which the photons are coming. So I don't know. I can't make much out of that either. So, you know, we're so far from talking the same language here that, you know, it sort of just moots the conversation in some way. Now the next critical point is that PLD method and the theta method produce different predictions about the coordinates of the maxima and minima. Well, I'm just the first thing we should agree on is that the central one is not being decided by two path lengths that are the same length pointed inside of 1/4 of a millimeter. So until we can agree on that the center maxima is not an on, okay, that the maxima really are to the left and to the right, and that's why there's a double maxima in the center. It's because it's not. It's two different nodes merged, which I think is a good thing. Predictions about the coordinates of the maxima, which I think is a good thing. So, well, obviously two completely different definitions of positioning the variables. You should get a different, like 3 plus 2.5 should be different than 3 plus 2. Yes. This is a good idea to have clear distinctions with a particle model argumentation. So again, I'm not sure again, I can't say for sure because you've gone a step further than I can go mathematically maybe. I'm arguing a particle model from these locations as pieces of a photon being scattered to all locations, and all you're doing is saying, can this path length difference, and it'd be a whole wavelength of this path length difference, and reestablish the same period between the event of landing here. Obviously, if I make this distance, if I make this line longer and longer to get to different points, you know, and over each permutation of moving it, I'm making the line longer, another, you know, path length difference of a full wavelength. I'm just saying that, you know, I have a starting point in time, And now these photons, it's not the fact that they travel further. The only reason why it's relevant is the further travel means they show up at a different time. And the time is the same period between the timed events. Right? That's the phase. It's not showing up at the same time, it's showing up in phase, where it's the same amount of time because of the longer travel distance at the speed of light. Anyway. Okay. Simple one. Let's see. It's a good idea to have distinctions with the particle model argumentation. PLD method is the simple one. Alright, so you do PWL divided by distance. So we have P is what? W is the width of the slit. I don't know. We know L, so we can agree on L. And I thought you would be dividing by the wavelength. So W is wavelength. Okay, so P is the distance to the target. No, L is the distance to the target, sorry. Anyway, theta method uses oscillating sine curves as usually taught in books. Well, they're just using the same argument that it's a clock, you know, and well, but anyway. It is said that the PLD method is an approximation to the more precise theta method. Well, I'm arguing the theta method obviously isn't very precise if they are comparing them as parallel lines, because you have to argue that doesn't make any sense. And so if they're establishing them as parallel lines, they're just basically saying, look, I can, you know, at any angle I can cut off one of them based on the distance. I'm just trying to think of what other aberrations that creates. Well, I'll save that for later. One average of the theta model is that it has, one advantage is that it has the intensity factor in it. So I would argue that all their intensity crap is just crap. You look at the actual patterns and you're not going to see it anywhere. So if that's a real argument, I'd say it's one that's going to fail. That they ever really tested any of those assumptions about intensity. But also the simpler PLD could have an inverse square rule to diminish the intensity. Well, obviously the fact that the nodes are spreading over more space would imply they have to become less intense because there's fewer photons per square inch. The fewer photons hitting the surface per square inch or square whatever micrometer is going to dictate brightness. So obviously the nodes that are getting bigger are getting dimmer, but they're not less photons going to those locations. It's just you're going to see less of them because the concentration is too low for your eyeball. Anyway, center maxima is a clumsy part of the model. There you go. So clearly I'm arguing you have to completely ignore the fake notion that there's two same length vectors. So obviously it has to be an on. That's just bullshit. So everybody should be able to agree that's bullshit. That was a misunderstanding. I mean, Professor Lewin was just wrong to say it's non-negotiable, you know, that the center maxima is an on. Because, no, that all happens within a tiny amount of space that's not diverging and therefore is not being magnified. It requires quite an ad hoc decision on what to do with the zero difference path lengths. So obviously the zero difference path lengths, you're not even keeping the same L, okay, because the line would have to get shorter, you know. So I mean, it doesn't work for lots of reasons. It doesn't exist as a real part of the fringe pattern. It's inside less than a quarter of a millimeter. It's just not relevant to everything that's happening fringe-wise. I notice that if you start with a constant L, either for a vector A or B, there you go, and let the other vector change relative to that, there is possibly no zero length difference in the middle. We can't place it at an L distance because the L has to get longer. I mean, you know, it's just a fact, so there's no place to put it. If you keep L the same, if you keep the arm the same length, it won't work because it won't be at the L distance. So it just can't work. Alright, center maximum PLD would always be some functional irrational number getting closer to zero, but never precisely a zero. Another way around says, I don't think you have to get around it, you have to just ignore it. Another way around would be to argue somehow that the PLD below the value of one wavelength is always light on. I don't know if that's, well, it's obviously saying, so if you have less than a wavelength of, less than a wavelength of difference in the points, yeah, you'd have to argue it's either all on or all off. It's a giant node. Whether it's an off node or an on node is a good question, maybe. And if there were a light off node in the exact middle, well, I think there has to be, but whatever, that would be always replaced by a direct light cone coming through the middle of the slit. Right, but if you're using the single impediment, you don't have that. You don't have any direct laser light, except the fact that, yeah, you do, because it's only 1/4 of a millimeter impediment, let's say, and the light shining from the laser can fill quite a lot of the space in the, you know, again, you're not going to see the 1/4 of a millimeter shadow, you know, at the target. Although the shadow is getting bigger and bigger, so it does help a little, but it can't undo the divergence of the laser beam that's going to fill part of the center. Alright, but it doesn't matter for what we're mathematically trying to do, right? The math, we can take those things out. We can edit out the divergence of the laser, and we can edit out this stupid little tiny bit of space where there's an on. We can just edit those out and say, what are the real fringes doing? And then we can just look at the real image and see, well, okay, the middle is blurred out. I can't see what's actually happening, but I can see all the others. So if I can predict all the others accurately, we'll, you know, go with the math and say, well, the math is saying there's two nodes that are next to each other, right? And the two nodes next to each other are looking like one big node. All right. I did a new GeoGebaba, whatever, document to simulate the difference between the two models. And I'm sorry, I couldn't really make much out of it. I also did a spreadsheet document to calculate the values for confirming the GeoGebaba document conjectures proposal. Right, so we have nothing to compare it to, which is just useless. So we have no real, like this is a real one, like a real scientist actually did the experiment and actually measured everything. So we don't have any really good, there's some images online you can get, you know, where they tell you, well, this was what we did. But the fact is a lot of them you have to be really careful because some of their images are just simulations. They're not real images, you know, which is really irritating. Anyway, so proposal. One could do an experiment to show whether the PLD method or the theta method will give a more precise prediction about the diffraction pattern. All we have to do is somebody just has to do one slit experiment where they actually measure, make sure the slit are what they say it is, measure the distance to the target, and then measure the size of the nodes. So it's not that demanding. Alright, if the slit width can be made less than 10 to 50 micrometers. Now see, this is where we diverge. Why would we want to do it with small numbers? Why does it have to be less than 100 to 50 micrometers? How does that help? bigger better, in my opinion. I mean, you don't want the nodes so small that you can't see them, but obviously bigger better. More nodes, more accuracy in a way. More definitive regarding where the centers would be in some respects. The screen's distance L can be placed somewhere from 4 to 10 meters, and a laser width laser wavelength should be 600 to 700 nanometers. Well, I don't know why these numbers you chose. You could use a blue laser and it's fine. I don't see the problem. But anyway, then we could have a view to the visible and a measurable difference. Yeah. So, I mean, it's just one of these things where, again, I've argued that physics is way undercooked. Everybody shouldn't be, again, they don't have any explanation why forces are interacting with forces, and now you have to understand that only the red light is interfering with red light, and the blue light interferes with blue light, and the green light interferes with green light, you know, exclusively. You know, these are not, no one's demand any explanation for how any of this crap happens, how these things do this stuff, and that part is just miraculous to me. But we can see how little evidence how little experimental data they've collected to confirm any of it. So they just tell you this is how it works, but there's no show me evidence here at all. It is all about seeing the length of the center node. Okay, let's see about this, what that says. It's all about seeing the length of the center node. There is no center node, so I'm just not going to allow this rhetoric to stand. Because what we're really arguing, okay, technically, I mean, there's a truth, and there's no point in, you know, if you keep conceding to their language, you know, what it is the double node. So that's what it should be called. And comparing it to the PLD method and the theta predictions. I don't think it has anything to do with how you're predicting. It has to do with understanding that things going in can't be magnified with distance, okay? You can't make it a bigger node. You can't make it spread. You can't magnify it. It's still inside of the 1/4 of a millimeter. No matter where I put it in space, it's still happening inside of 1/4 of a millimeter, and it can't possibly be, you can't have two lines going this way and then they diverge this way. If they cross each other, they won't be at the same point. They have to hit the same point, and they can only hit the same point inside of that 1/4 of a millimeter. So there's just no way they can create a node that gets bigger with distance. And we all should be able to agree on that. So that's not the real description of the starting point. The starting point is you have a straight line on this side, okay, with a little right angle, and now you take this side and connect it, okay, and then you can do, you know, you have your three sides, two sides, you can predict your third. So you know, I showed you one of the links. I mean, it's just not, you know, you know, I gotta go to this again, but I mean, it just doesn't. All this advertising. Yeah, I mean, this is just not really, you know, doesn't help me any. Okay, and especially adjusting. I don't know what these adjustments are. I mean, these adjustments are like, well, adjust how wide the slit is. That's not an adjustment here, as far as I can tell. So yeah, I can't make much out of it. All right, so then he says, UNSW Physics presented a nice set of equipment for the slit experiment, but I can't see if they have published any results. So this goes back to arguments I had with the troll, you know, who presented. So there's this is just a video of what I've already shown. So I'll open this one, a new tab. This is the $5,000. Look at that, they have commercials on a company website that's supposed to be trying to sell their own products. It's funny. All right, so this is the $5,000, okay, slit experiment toy, I'll call it. So there isn't much to it, frankly. And so it does it with two different detecting methods, a diode, and then you can do the more sophisticated experiment with the photomultiplier. So this is what the thing Veritasium used to do the experiment. And so that's a really famous 4 million view kind of experiment, where I pointed out how clearly the whole thing was a fraud because Veritasium couldn't get it to work, and the only way it could get it to work is you had to turn the photomultiplier all the way up to the highest sensitivity, which meant he was getting a ton of random spatial, whatever you want to, he was getting a ton of heat photons, okay, error photons. And because the error photons were so high in number, he had to shorten the distance in which he made the experiment happen. So instead of letting it run all day, he had to let it run for just 5 minutes. And so he, used mathematical tricks to say, well, it's still theoretically 1 photon at a time, but that's because theoretically you can make a photon any size you want to. If you make a photon this big, okay, then you're saying, what's the likelihood of these 2 photons being in the same space? Well, it's really small because they're little tiny things. But if you make a photon this big, then there's all kinds of overlap possibility. And at a certain size, overlap becomes inevitable. So it just depends on how long you think a photon is. So that math trick is just that. It's just a math trick. Well, anyway, so I already did a couple of videos debunking that video because it's a pile of crap. What he claims to have proven he didn't prove. Single photons still creating the pattern. Alright, and then there is another video by a Christian scientist. I don't even know if he's a Christian physicist, let's put it that way. And the gimmick is that you can buy this. The $5,000 kit comes with a noise filter, okay, ironically. And what does it do? It filters out when there's too many photons, right? So the too many photons, it starts filtering out the photons. So obviously, if you want to make the experiment look like photons are disappearing, the filter will do it for you. Anyway, so lots to critique in terms of this thing being a credible schematic of how to do the experiment. This isn't the ideal. All right. So, so I don't think it's a nice set of equipment. I think it's way overpriced, frankly. $5,000 for really just a photodiode. That's the, that's the expensive part of it, and the rest of it's just, bullshit. Not very expensive tools, let's just say. So, yeah, I mean, if somebody gave it to me for free, I'd be happy. But yeah, I wouldn't pay $5,000, that's for sure. Anyway, so yes, I've been there, done that. And there's still lots to critique there in terms of getting any real data. And when Veritasium did it too, the real disappointing fact is the range of this toy is so bad that you don't even, you're just detecting light in the central maxima, so to speak. You're not, the envelope pattern is again dismissed as irrelevant. It's not something you can use to detect the envelope because the distances are so short, and the range of your photodiode and photomultiplier is always inside of that central maxima of the envelope pattern. So it doesn't even do you any good to do a double slit experiment because you're not even capable of running across the range of the actual slit experiment. You're stuck inside a tiny portion of it. Yeah, so there's lots to critique there. So I appreciate your continued work. I guess what I would just be interested in is this. Again, if I know 2 of these lengths, if I know this length and I know this length, and all I want to know is this hypotenuse, is there some simple way I can do that mathematically, and then just fill in all these numbers? So I can just I can predict all of these numbers on this whole arc because I'm just doing this triangle thing, moving the triangle through. So that, you know, there should be some math trick that does that. I have two sides of a triangle and I just want to know the other side. It's got to be even without the other angle. I mean, I know side angle side, but is there a way just to do the two sides and get that third side? Because that's all, you know, a simple way to do that, and yeah, then this is going to be easy. Because I just create a program that does that math over and over and over again and just tells me every point in space. So, make it really easy. Alright, anyway. So, till the next time and such. That seems like enough of a video. Yeah. No other sensible comments, frankly. Not one's near the subject. So anyway, yeah, so that's enough of a video. Well, alright, so till the next time and such, I don't think there's anything else to mention. I don't think so. Alright, so, this has been a DraftScience video presentation. Till the next time and such.